Illinois, electrical system designs typically necessitate certification by a registered professional engineer or an individual experienced in electrical design, as outlined in the Illinois Department of Professional Regulations Manual for Code Review Officials. This manual indicates that electrical drawings for buildings in Illinois are generally required to be signed and sealed by a registered professional engineer. It is important to note the National Electrical Code, or NEC, does not explicitly mandate that electrical drawings be signed and sealed by a professional engineer. However, Section 90.3 of the NEC states that electrical installations designed and installed in accordance with the NEC shall be acceptable as meeting the minimum requirements of the NEC. This provision implies that the NEC does not override local or state regulations concerning electrical design and installation, which may include the requirement for a professional engineer's signature. Similarly, the International Building Code, or IBC, does not explicitly demand that electrical drawings be signed and sealed by a professional engineer. Nevertheless, Section 110.3 of the IBC stipulates that the authority having jurisdiction, known as the AHJ, responsible for enforcing the IBC shall be the building official. This section grants the authority having jurisdiction the power to mandate a professional engineer's signature on electrical drawings if deemed necessary for public safety. The final determination regarding whether electrical drawings must be signed and sealed by a professional engineer rests with the local building code or permitting authority. Although the city in question has adopted the NEC and IBC, there may be additional local requirements pertaining to electrical design and installation. While it may not be universally common practice for electrical drawings to be signed and sealed by a professional engineer, it is advisable for complex or high-risk electrical systems. A professional engineer can offer an independent assessment of the design and ensure compliance with all relevant codes and standards. Considering the information available, it is probable that electrical drawings for a megastore in Illinois will need to be signed and sealed by a professional engineer. Previous experiences may not be relevant to the current project, as local code requirements are subject to variation. Consulting with the local building code or permitting authority to confirm specific requirements is always recommended. Let's delve deeper into the considerations surrounding electrical drawings and the necessity of a professional engineer's involvement. Firstly, it's crucial to understand the role of a professional engineer. A professional engineer is licensed to practice engineering and is held accountable for their designs and work. Their seal on a document signifies that they have taken responsibility for the design's adherence to applicable codes, standards, and safety practices. Secondly, consider the complexity of the electrical system. A megastore typically has a substantial electrical load, intricate distribution systems, emergency power systems, and specialized equipment. These complexities increase the risk of design errors or omissions, making the involvement of a professional engineer more critical. Thirdly, explore the liability aspect. If a design error leads to property damage, injury, or loss of life, the designer could be held liable. A professional engineer's involvement can help mitigate this risk by providing a thorough review and validation of the design. Fourthly, analyze the role of the authority having jurisdiction, or OJ. The authority having jurisdiction has the ultimate authority to approve or reject a building design. The authority having jurisdiction may require a professional engineer's seal to ensure the design meets all applicable requirements and protects public safety. Fifthly, evaluate the benefits of a professional engineer's review. A professional engineer can identify potential design flaws, ensure proper coordination between different electrical systems, and optimize the design for energy efficiency and cost effectiveness. Sixthly, check the specific requirements of the local building code. Building codes vary from jurisdiction to jurisdiction, and it is essential to determine the specific requirements applicable to the project. The local building code may explicitly require a professional engineer's seal for certain types of electrical systems or buildings. Seventhly, investigate the insurance requirements. Some insurance companies may require a professional engineer's seal on electrical drawings as a condition of coverage. Eighthly, consult with experienced electrical contractors. Electrical contractors who have worked on similar projects in the area can provide valuable insights into local requirements and best practices. Ninthly, understand the implications of not obtaining a professional engineer seal when required. Failure to comply with local building codes can result in fines, delays, and legal action. Tenthly, consider the long-term benefits of using a professional engineer. A well-designed and properly installed electrical system will provide reliable and safe operation for the life of the building. A professional engineer's involvement can help ensure that the system meets these goals. Beyond the immediate considerations, the decision to involve a professional engineer in electrical design extends to long-term operational efficiency and safety. Professional engineers are trained to consider the entire life cycle of a building's electrical system, from initial design to future maintenance and upgrades. One aspect often overlooked is the importance of load calculations. A professional engineer will conduct thorough load calculations to ensure that the electrical system is adequately sized to handle the building's current and future electrical demands. This helps prevent overloading, which can lead to overheating, equipment failure, and even fires. Another crucial consideration is coordination studies. Coordination studies analyze the interaction of different electrical components to ensure that they operate safely and effectively together. This includes selecting appropriate overcurrent protection devices, such as circuit breakers and fuses, to protect against short circuits and overloads. Short circuit studies are also essential. A short circuit study determines the magnitude of fault currents that could flow through the electrical system in the event of a short circuit. This information is used to select equipment that can withstand the fault currents and to ensure that the overcurrent protection devices will operate properly. Grounding is another critical aspect of electrical design. A properly grounded electrical system helps to protect people from electric shock and to prevent damage to equipment. A professional engineer will design the grounding system to meet the requirements of the NEC and other applicable standards. Surge protection is also important, especially in areas prone to lightning strikes or power surges. A surge protection device, or SPD, can help to protect sensitive electronic equipment from damage caused by voltage spikes. A professional engineer can help to determine the appropriate surge protection for the building. Energy efficiency is another important consideration. A professional engineer can help to design an electrical system that is energy efficient, reducing energy costs and minimizing environmental impact. This includes selecting energy efficient lighting, motors, and other equipment, as well as designing a system that minimizes energy losses. Commissioning is the process of verifying that the electrical system is installed and operating correctly. A professional engineer can oversee the commissioning process to ensure that the system meets the design requirements and that it is operating safely and efficiently. Regular maintenance is essential to keep the electrical system operating properly. A professional engineer can develop a maintenance plan that includes regular inspections, testing, and repairs. This helps to prevent problems before they occur and to extend the life of the electrical system. Upgrades may be necessary over time as the building's electrical needs change. A professional engineer can help to plan and implement upgrades to the electrical system to ensure that it continues to meet the building's needs. In addition to these technical considerations, a professional engineer can also provide valuable assistance with project management, code compliance, and communication with stakeholders. Project management involves coordinating the various aspects of the electrical design and installation process, including scheduling, budgeting, and resource allocation. Code compliance is ensuring that the electrical design meets all applicable codes and standards. This can be a complex and time-consuming task, but a professional engineer has the knowledge and experience to navigate the code requirements effectively. Communication with stakeholders is essential to ensure that everyone is informed about the electrical design and installation process. A professional engineer can communicate effectively with building owners, contractors, and other stakeholders to ensure that the project is completed successfully. In conclusion, while the NEC and IBC provide minimum requirements for electrical installations, Local building codes and the authority having jurisdiction often have the final say in determining whether a professional engineer's seal is required on electrical drawings. For complex projects like a megastore, involving a professional engineer is highly recommended due to the intricate electrical systems, potential safety risks, and long-term operational considerations. Consulting with the local building code or permitting authority and engaging a qualified professional engineer are crucial steps in ensuring a safe, efficient, and code-compliant electrical installation. Moreover, the selection of electrical equipment and materials should be carefully considered. Opting for high-quality, reliable components can significantly reduce the risk of failures and downtime. Professional engineers often have extensive knowledge of various manufacturers and products and can recommend suitable options for specific applications. Proper installation practices are equally important. Even the best designed electrical system can be compromised by poor installation. It's crucial to hire qualified and experienced electrical contractors who adhere to industry best practices and follow the professional engineer's specifications meticulously. Regular inspections during the installation process can help identify and correct any potential issues before they become major problems. Documentation is another critical aspect of electrical system management. Accurate and up-to-date documentation, including as-built drawings, equipment specifications, and maintenance records, is essential for troubleshooting, repairs, and future upgrades. A professional engineer can ensure that all necessary documentation is properly prepared and maintained. Training is also essential for personnel who will be operating and maintaining the electrical system. Proper training can help prevent accidents, minimize downtime, and extend the life of the equipment. A professional engineer can develop and deliver customized training programs tailored to the specific needs of the building and its staff. Continuous improvement is a key principle of effective electrical system management. Regularly reviewing the performance of the electrical system and identifying opportunities for improvement can help reduce energy consumption, minimize maintenance costs, and enhance overall reliability. A professional engineer can provide valuable insights and recommendations for continuous improvement. Furthermore, the integration of smart technologies can enhance the performance and management of electrical systems. Smart technologies, such as smart meters, energy management systems, and automated lighting controls, can provide real-time data on energy consumption, identify potential problems, and optimize system performance. A professional engineer can help to select and implement smart technologies that are appropriate for the building's needs. Resilience is an increasingly important consideration in electrical system design. Resilience refers to the ability of the system to withstand disruptions such as power outages, natural disasters, or cyber attacks. A professional engineer can design the electrical system to be more resilient by incorporating features such as backup power systems, redundant components, and cybersecurity measures. Sustainability is another key consideration. A sustainable electrical system minimizes its environmental impacts by reducing energy consumption, using renewable energy sources, and minimizing waste. A professional engineer can help to design a sustainable electrical system that meets the building's needs while minimizing its environmental footprint. In addition to these technical considerations, there are also important ethical considerations to keep in mind. Professional engineers have a responsibility to protect public safety and to act in the best interests of their clients. This includes providing honest and unbiased advice, avoiding conflicts of interest, and adhering to the highest ethical standards. Engaging a professional engineer with a strong commitment to ethical practices is essential for ensuring the integrity and reliability of the electrical system. Furthermore, ongoing professional development is crucial for professional engineers to stay abreast of the latest technologies, codes, and best practices. Participating in continuing education courses, attending industry conferences, and engaging in professional organizations can help professional engineers maintain their competence and provide the best possible service to their clients. The selection process for a professional engineer should be thorough and comprehensive. It's important to consider the engineer's qualifications, experience, reputation, and communication skills. Checking references, reviewing past projects, and conducting interviews can help to ensure that you select the right engineer for the job. The contract with the professional engineer should be clear and comprehensive, outlining the scope of work, deliverables, schedule, and fees. It's also important to establish clear lines of communication and to define the roles and responsibilities of all parties involved. Regular communication and collaboration throughout the project can help to ensure that it is completed successfully. Finally, it's important to recognize that the electrical system is an integral part of the overall building design and operation. A well-designed and properly maintained electrical system is essential for providing a safe, comfortable, and productive environment for building occupants. Investing in a qualified professional engineer and following best practices for electrical system design, installation, and maintenance is a wise investment that will pay dividends for years to come.